Okay, so today we're going to go through our second day of review for the Keystone exam. So we're still on Module 1, and we're on question number 9. So we have Ingrid, and she is collecting autographs. The first bullet says she started her collection with X autographs. So I'm going to just start with the variable X. Then she doubled the number of autographs in her collection. So, for example, if there were 10 autographs in her collection, if she doubles it, she now has 20. If there were 20 autographs in her collection, if she doubles it, now she has 40. So we're basically multiplying the original value by 2. So we have X autographs, so to write 2 times X, we write 2X. Then it says, later, she received 3 additional autographs in the mail. So we're going to add 3 more autographs. Then it says she now has between 85 and 90 autographs. So this is how many autographs she has, and that number is between 85 and 90. So how is that written as an inequality? So the answer choice is C. And you can see that we separate each of the parts with a less than symbol. Let's move on to problem number 9. In problem number 9, we have Rahiv, and he unpacks one box that has 8 books in it. He has 4 other boxes that have X books in them. He knows he has at least 80 books. The inequality below represents this situation. And then they ask which graph best models all the possible number of books in each of Rahiv's 4 other boxes. So we're going to basically solve an inequality. So we have 4x plus 8 is greater than or equal to 80. So in your algebra class, you learn to use opposite or inverse operations. So the opposite of adding 8 is subtracting 8, and whatever I do to one side, I want to do to the other. So that gives me 4x is greater than or equal to 72. And then when I divide both sides by 4, to get rid of my 4, I get my answer, which is x is greater than or equal to 18. Now, before we look at our answer choices, let's just draw the graph. So 18 is the number we're looking for on the number line, and since this has a line underneath, we would put a closed dot, and we're going to point the way this is, shade the way this is pointing, so we would be shading in this direction. So that looks like answer choice B. Let's look at problem number 11. So in problem number 11, we're given a system of inequalities to graph, and we are given graphs to choose from. So again, before we look at the graphs, let's analyze what we have here. So first we have x is greater than or equal to -2. So if you recall from your algebra course, this means you would have a solid line at x equals -2, and then the shading would be to the right. And y is less than 3 means you would have a dotted line at y equals 3, and you would shade below. And the reason that you're shading below is because it's less than, and above because, or to the right because it's greater than. Now we have to figure out which graph is our answer. So these 2 graphs, graph A and graph B, are going to get eliminated because the shading is above and to the left. So this is above this line, and this is to the left of this line, and both of these are similar. So these are getting eliminated. Then when I look at the next 2, they're the ones that I want to pick from because it's to the right and below the line. but I have to make sure I correctly pick the dotted versus the solid line. So it says that at x equals -2, I should have the solid line. So this has a dotted line at -2, so I'm going to go ahead and pick answer choice D because it has the solid line at -2 and the dotted line at y is equal to 3. For the next problem, you are asked to tell what the solution to a system of inequalities represents. So it's just a matter of, you don't have to solve it, you just have to say what the point represents. So let's read through the problem carefully. It says Laura is buying bottles of water and bottles of lemonade. So we have two types of drinks. She's buying water and lemonade. She needs to buy at least 6,400 ounces of beverages between the water and the lemonade. Each bottle of water is 20 ounces and each bottle of lemonade is 30 ounces. Laura has a budget of $600 to buy the beverages. The system of inequalities below represents the situation. So what we need to do is figure out what X and Y are. So we have water and lemonade. So if you'll notice, it says each bottle of water is 20 ounces. So here is that 20 ounces, and it's being multiplied by the variable X. This is important because it's telling us that X is the water. So X is the number of bottles of water that they are going to buy. And then when we look at Y, Y has to be the lemonade. And again, it's the same thing. It's the number of bottles of lemonade. Now they say one solution to this system is 4180. What does this solution represent? So again, before you go looking at your answers, write it down. So points are in the form X, Y. So 40 represents the number of bottles of water. So we have 40 bottles of water. And then Y has to be the lemonade. So it looks like we have 180 bottles of the lemonade. So let's find the answer. It says by buying 40 bottles of lemonade. Well, it says we bought 180 bottles of lemonade, not 40. So that's out. By buying 40 bottles of water, well, that's how many bottles of water we bought, and 180 bottles of lemonade, that looks good. Laura will have at least 6,400 ounces of beverage and stay within her budget of $600. Well, that sounds great. That sounds like the answer. So the answer is answer choice B. Now we're going to go to the constructive response questions. So in the constructive response questions, you want to make sure that you create your answer. So you don't have an answer choice anymore. Now you have to create an answer. Remember, you have as much time as you need to take on these, so take the time to get something out of the problem. So we have Landry, and he's working with the expression 2 root 18x. We want to determine an integer value of x less than 10. So an integer value of x less than 10 for which 2 root 18x is a rational number. So we're being tested on what kind of number systems we have. So first, we have an integer. So what is an integer? An integer is all your positive whole numbers, so 1, 2, 3, etc., 0, and then all your negative ones. Now, we're going to eliminate the negative ones because we're dealing with a radical. And when you take a square root, you can't take a square root of a negative without going into another number system. And then a rational number is going to be anything that can be written in the form A over B. So basically, we do not want repeating decimals or we do want repeating decimals or terminating decimals. So let's see if we can figure out what the values are. So 0 is going to be boring because that's going to be 0. So we're actually going to eliminate that as well. So we're just going to deal with numbers like 1, 2, 3. So let's make a little table here. And we're going to look at the value of 2 root 18x. And we're going to look at first the value 1. So we can just put this into our calculators if we want to, because we're allowed to use a calculator. So if I put 2 root 18 times 1 in my calculator, I get approximately 8.48, and then it goes on and on and on and on and doesn't stop. So that's not rational. So we need to move on. So let's go to 2. So now if I take 2 times the square root of 18 times 2 in my calculator, that gives me 2 times the square root of 36, and the square root of 36 is 6. So 2 times 6 gives me a nice whole number or integer value of 12. So 12 is a rational number. It stops. It can be written as a fraction as 12 over 1. So that's the answer. Now, if you're not careful, you're going to write this 12 on this line, but we're not going to do that. It says, what's the integer value of x? So what did we multiply by? We multiplied by this 2. So the answer is 2. Now, in your construction response questions, we're going to stay with that function, and we're just going to keep building upon the questions you have already been asked about it. So the second part asks you, write an expression that's equivalent to 2 root 18x and is in the form a root bx, where a and b are positive integers, and a is not 2. Okay, so in order to do this, this is the kind of stuff we probably would have done more often in class. So if we look at the number 18 and we break it into pairs and spares, we can break this down into 2 times 9, and then 9 breaks down into 3 and 3. So here is our pair, and this is our spare. So if we rewrite our expression, it's 2 times, and then we take the pair out as a single 3, and then a root of, and we're replacing that with 2 and x. And the 2 is our spare, and the 3 is our pair. So 3 goes on the outside, 2 goes back inside, and then we're going to simplify. So 2 times 3 is 6, and we just have a root of 2x. So that's one way it could be simplified. So it's in this form where a is 6, b is 2, and there's x. So this is one way. There might be other ways to do it, but this is an answer, and that's probably the answer most people are going to get. In part 13C, we are asked, what's the largest integer value of x for which 2 root 18x is less than 36? So for this one, I would again suggest you make a table and start throwing some integer values into your function, which is 2 root 18x, and see when it starts to become less than 36. So if you start with an x value of 1, and you put that into 2 root 18x, it's 2 times root 18, which is about 8.5. And that's definitely less than 36, quite a bit less. So we need bigger numbers. So let's go up to 5 and see what happens. So now we're taking 2 times root 18 times 5. And when I did that, I got 18.9. Still less than 36, so it's not the largest. We can go more. So how much more? Well, let's go up to 10. So if I take 2 times root 18 times 10, I get 26.8. We're getting closer, but we can probably still find a bigger one. Let's go to 15 and see where we are. So 2 times the square root of 18 times 15 gives you 32.86. We're still less than 36, but I think we can go up some more. So let's start going up by 2. So let's do 17. So 2 times root 18 times 17 is 34.99. So we're even closer. I think that's probably the largest. If you would go on to look at 18, 18 ends up being exactly 36, and this ends up being less than, only, not less than or equal to. So this is the largest one that will still be less than 36. So the answer is 17. Last one for today. So we're asked to determine all the integer values of x for which 2 root 18x is greater than x squared, and 2 root 18x is also greater than 8 over x. So we're being asked to compare these 3 values for integers and see what happens. So again, I'm going to go ahead and make a table. So I'm going to put x squared first, 18 over x second, and then the last one is going to be the 2 root 18x. We're going to exclude 0 because we can't divide by 0 in this second function. And we're going to start at 1. And we want these 2 columns to always be smaller than this column. So let's start with 1. 1 squared is 1. Let's move on to 2. 2 squared is 4. Moving on to 3. 3 squared is 9. Moving on to 4. 4 squared is 16. And moving on to 5. 5 squared is 25. So those are the values, or some integer values, of x squared. Let's use the same values with 18 divided by x. So 18 divided by 1 is 18. 18 divided by 2 is 9. 18 divided by 3 is 6. 18 divided by 4 is 4.5. And 18 divided by 5 is 3.6. Now let's get all these same x values for 2 root 18x. So we're going to take 2 times the square root of 18 times 1, which we actually did earlier, which is 8.5. And then we're going to take 2 times the square root of 18 times 2, which is 12. Then we're going to take 2 times the square root of 18 times 3, which is 14.7. Then we're going to take 2 times the square root of 18 times 4, which is 16.97. And then lastly, we're going to take 2 times the square root of 18 times 5, so that gives me 18.97. And we could keep going, but let's see where this gets us. So for this x value, we want these 2 columns to be smaller than this. For x equals 1, that does not happen because 18 is more than 8.5, so it doesn't work for that. For 2, these are both less than 12. For 3, these are also both less than 14.7. For 4, these are also both less than 16.97. Obviously, 16 is just less. And for number 5, these 2 are not both less than 18.97. The 25 is more than it. So it's probably going to stop working after 5 because of the power of the exponential function. And it didn't work for 1 either. So the answer is 2, 3, and 4. We're going to start Module 2 tomorrow.